Farming Forecaster Tassie webinar, and it's going to follow a similar format to the workshops that we've done. Now, there's a few new people, so what I'll do is I'll just give a quick introduction to a few people on the webinar, and then just do a little bit of a brief intro to what Farming Forecaster is, what's happening in Tassie right now, and then I'll hand over to Phil to do his presentation. So during all the discussions, we've obviously got the chat function. Yolanda's looking at the chat, but we'll both look at that. So if you've got any questions, we can put them in the chat, and we'll have about 5-10 minutes at the end to talk about those. If you want to raise your hand during Phil's presentation for any specific questions, please do as well. So we'll get started. So my name's Tim Ackroyd. I am an Ag Project Officer for NRM South. So I started getting involved in this project. It was actually the East Coast primary producers, who we have members here today, who instigated this whole pilot on Farming Forecaster a couple of years ago. So we ran a pilot for the tool, which is now sort of rolled up a couple of months ago, but we then got some funding to do a further investment in Farming Forecaster, and that's a statewide project, and it's NRM South and NRM North. And so as I'll give introductions, we've got Peter Heading from NRM North here, and myself, Peter, and a couple of other staff here at NRM South are working together on this project, in conjunction with many other people. So we've also got Phil Graham. So Phil is the livestock advisor who's working closely with us on Farming Forecast, and he's had a lot to do with development of this tool in New South Wales. And so he's working with us on this larger project as well. So he's the one. So Phil will be presenting on what's happening in Tassie on the sites that we've already got. And then we also have Marek here. So Marek is from AgLogic, and we're working with AgLogic to set up all the probe sites, which is a component of this tool. So Marek is a bit of an expert on tech and soil moisture, probes, weather stations, etc. So he's working with us on this project. So Yolanda and James are other members of the NRM South team. So James is our manager for the land program, which is where this project sits, and Yolanda's part of the land program as well. So I hope I haven't missed anyone. So just a bit of an introduction to what this tool is. So it's a decision support tool for graziers. It was developed in New South Wales with CSIRO. And the Monero farming systems and various other farming system groups. So what it does, it basically uses real-time information on soil moisture and rainfall and weather data, and a seasonal outlook on pasture growth, to give people an idea of how rainfall and soil moisture affect pasture production. So it's a tool really to give people an insight into what their available feed is up to 4 months ahead of time, and therefore is a really powerful planning tool. So it comprises a soil moisture probe and rain gauge, alongside a sophisticated farm model system, which gives you that pasture curve, growth curve predictions 3 to 4 months ahead of time. So all of that information is all on one website. Currently, that's a publicly available website, so anyone can look at any information that's generated from that technology on someone's farm. So it really it's a tool that takes a bit of risk out of farming decisions and gives the industry some confidence to plan ahead, particularly when you're coming into a drought scenario, which of course at the moment we're not, but at some point soon we will go into a drought. So it's helping improve commercial success for farmers, but it also is an effective tool for natural resource management, such as ground cover. So that's particularly why we're very interested in the tool. So Farming Forecaster is now available in Tasmania. We've got 13 sites established from the pilot. And now this new project that we've got up and running, we're now looking to establish 30 additional sites across the state. And we're going to be working with North and to some extent with Cradle Coast to get those other 30 sites up and running. So we're already in discussions with many farming groups and we've got quite a bit of interest. So this is going to be expanded and there'll be more reference sites for people to look at. So the important thing is that sites are hosted by a farm, but the information that's generated from those sites is useful to neighbours and other people with similar conditions. So what we're trying to do is create this network of sites that is useful not just to a host who has the site, but to a whole range of other farmers and advisors who use that information. So that's a little bit about the tool. So I'll shortly hand over to Phil. He's going to talk about the outlook for each of the sites for the East Coast in this session, but we'll also look at a couple of other sites and how this information is useful to people with similar farms. We'll also look at compare the new function on the tool. So the tool uses historic data to generate the pasture forecast, but it also has another function that's just come on board called Access S, which uses the long range forecast. So it's going to give us a bit of a comparison between those two. Yeah, so I will hand over to you, Phil, to start things off.
Thanks, Tim. Good afternoon, ladies and gentlemen. We'll get into it. Initially, I just want to go through a number of slides as a bit of background information and getting people's heads in the right space. So here's a picture of the projected pasture. Really what I want to achieve on this, we have any shading is the historical data. So that's based on the pasture that would have occurred for the planting period from the last 30 years. So the weather we're using to generate that 30 years is the weather from the 1st of January 1992 through to the end of 2021. So there's 30 years of, this is green pasture, 30 years of pasture data, and we've displayed it on a percentile basis. And then the coloured lines are the forecast, what it's saying is happening in the next 4 months. But the reason for the arrows is just to show where they line up. So the red line is the 10 percentile, the 1 in 10 chance of the future. Where's the 1 in 10 chance of history? It's sitting down here at the intersect of the white and the red. The brown is 25%. Where's its equivalent historical? That's between the red and the brown. The yellow is the median line, the 50%. Where's its historical point? It's where the brown hits the green, and the blue, its reference point is the top of the green line.
Sorry, Phil. I think I may need to stop sharing. I think because I don't think anyone else can see the graphs. Can they? How do I stop sharing? Okay. How's that, Phil?
I have nothing.
Yeah. So it might be I have to share. I have to run it. Sorry, everybody. Can everybody see that now? If I change to the next slide.
Yep.
All right. I'll drive it. I'll drive it. You just tell me, Phil.
Rightio. Well, we'll go back. This is the pasture stream that's come up. The shading is historical data. I suppose you heard what I said, so I maybe don't need to go through all that again. But I'm trying to give you relevance of where the red line and its equivalent historically should sit. So at present in Tassie, and what we're seeing is very similar to this, is that the current position is very high up on the historical data. The 10% line historically is where that boundary of the white and red is. Where the red and the brown meet, that's the 25% historical. Where the brown and the green meet is the 50% historical, and the top of the green's the 90%. So if the forecast was running the same as the historical data, the red line should be sitting down somewhere near the historical 10%, and all the lines should be, again, down somewhere near the historical band. So what's it's telling us at present? This is telling us that the forecast is sitting well above where historically we would expect to be. So it's one of the key things you do. You're comparing the historical data with the forecast data, and you're looking how the corresponding percentiles, how does the 10 percentile historically sit historically with the forecast? Next slide. As Tim mentioned in his introduction, we've now got two ways we can show. We use two lots of different weather set to do the forecasts. You can see the buttons up in the top right-hand corner of the graph, climatology and access. What's climatology? It's actually using the actual weather measured at that site based on the 5 kilometre grid for the years 92 to 201. So it's based on actual weather that has occurred in that region for the planning period. Whereas Access S is a program that sits in the Bureau of Meteorology, and every day the Access program generates potential daily weather for the next 3, 4, 5 months. We're using 4 months. Access S generates 11 of those data sets a day. Now, because we use 30 years of historical data, we need to use a similar number of years to generate for the future data. So what we do, if you look at, we've just started in August, what the Soro computer in Hobart would have done, it would have picked up the 11 files generated by Access S on the 28th of November, and then it picks up the 11 files generated by Access on the 29th of November, and it picks up the 11 files generated by Access on the 30th of November, puts them all together, and then we have 33 projected daily weather sets for the next 4 months. And what Access is doing is taking account of current climatic conditions that are influencing Australia. So what's happening in the Pacific Ocean, what's happening in the Indian Ocean, what's happening in the Great Southern Ocean, what's happening in the Tasman Sea, which way are winds blowing, where's cloud, all those things that make up weather forecasting. They take that information in, and every day they generate 11. So we're comparing 30 years of actual data to 30 years of future data. That's the difference between the two. Next slide, please. So I'm just going through a few little things to pick up, and then I'm going to go through actually each site. So this is one of the Tassie sites at present. And the reason I've just thrown this up, over the last sort of 4 or 5 days, the probe site has suddenly shown, no, gone one slide too far.
Yeah, sorry, clicked something. Apologies. Back in.
The probe site's actually showing that the top 3 bands are all at 0, as you can see. And there's been a massive drop. If you look at the 7-day change of moisture of 30% in 7 days, which is something I've never seen. You know, less than a week ago, this site had numbers up in the 10, 20 and 30 in the 30, 40%. So something's not quite right to me. And I thought, well, let's just go and check what the moisture model in the program's working. So we always, for every site, you have the probe information if there's a probe in the ground shown on the left, but within the model itself, so when you click the more pasture detail, you get this graph comes up. So the red dot is saying where is current soil moisture, and it's comparing it to the historical soil moisture for exactly the same 3 days over the last 30 years. Now that it's called a I forget. Oh, it's gone out of my mind. Anyhow, the box says there's 30 years data in the box and whiskers. So the line in the middle of the box is the 50%. So 15 years are below that line, 15 years above. The top of the box is a 75%, and the whiskers up at 95%. So what that is saying in the moisture model at present is that site, soil moisture for this time of year is at levels very rarely seen. So as on the day I downloaded this, what the probe's telling us and what the model's telling is we have some differences. Normally they are very, very close together. So I'm not quite sure, but something isn't quite right with those top three readings. But we've got some other data to continue driving the system. Next, please. A new feature, well, it's not a new feature, it's just because the length of time we've been running in Tassie's increasing, it becomes available. So the top graph is just what you can all see and have been able to see from the start, a graphic representation of the last 12 months of soil moisture for the 6 sensors. Now, if you look above that graph, there's this word compare to year, and there's a drop-down box, and now in that box it says previous year. So I've gone into that drop-down box, clicked previous year, so that's brought up the bottom of the graphs. So this at this site, the probe started working for the first time on the 26th of October in 2021. So we've got the last 12 months is in the top graph, and then the second graph we have the previous year's data. Now, if that was a full 12 months, you'd have a full 12 months of soil moisture. So you'd be looking at the last 12 months on the top and the previous 12 months below. So as time goes on, you're going to, at every site, you're going to be able to look at not what current soil probe moisture, but also historical. So if we look at it right now, what's this saying? At this time last year, your soil moisture was starting to drop off quicker, and your soils were slightly drier in 21 than they are in December 22. We can just see the graph starting to dry off in 22, but they'd substantially started earlier. So it depends on when the probes went in at sites, when that bottom graph will become available, but certainly by autumn next year, where it'll become more critical, you'll be able to look at 2 years, and producers in New South Wales are finding that very handy to be able to just quickly look back, where was moisture at this time last year? Thanks, Tim. Now we come on to this drought lot warning. So it appears, so a capacity came into the program about 3 or 4 months ago, that if ground cover becomes an issue, all stock are moved off pasture into a drought lot. So if that occurs, this warning sign comes up. When that feature first went up, it only took 1 day for it to be triggered. And it was just being triggered too much and for information which in reality was rather meaningless. So what we've done now is we've reset the trigger. So if the number of days that the stock are in the drought lot exceeds 10%, this drought lot warning will come up. Next slide, please, Tim. So if you just look at the 3 pie charts, the greens represent stock on pasture, the red is times the animals might be in the drought lot if seasonal conditions are going pear-shaped. So that's 10% at the top, 40% in the middle, and 90% in the drought lot across the 3. All of those 3 things gives you exactly the same warning. If the warning's triggered, if the rule's broken and they move in the drought lot, you just get that warning. The warning doesn't tell you how severe it is. Now, there's an enormous difference between the top one and the bottom one. So once the warning comes up, for us to work out how severe the activation of the drought lot is, we need to go to the very bottom graph. So again, we click that big blue more pasture data. We go right to the bottom and there's a graph there. You can see the heading, total supplements fed in drought lot. And then what we're doing is we are looking at what percentage of time do we have to feed. So this is in fact an example where the adult stock are being fed, and this is a cattle operation, they're being fed 100% of the time, and it's a substantial amount. You've got 100% chance that you're going to have to feed those stock that amount of food in the planting period. So that's telling you that the ground cover rule must have been broken quite a few times, because the stock will have spending a lot of time in the drought lot. If it's activated, if it's activated for 20% of the time, the amount of supplement you're feeding down the bottom will just get smaller and smaller. So the warning tells us it's been activated, but we have to go down to the total supplement graph to decide, is it a warning I really need to pay some attention to, or is it a warning that, yes, it's happened, but the chances is that low, I can almost forget about it. Now, hopefully we don't have to focus on that bottom graph for a while, but that is something, obviously, we'll get to a point in the life of this project where we will start having to pay attention to it. Next one, please, Tim. Just moving over to a different site. This is one in the Midlands. You'll just notice how quickly, historically and the forecast, how quickly the green feeds dropped off. And at this site, which would be one of the drier sites we've got active at present, you'll notice, say, historically, that there's virtually no green feed from, maybe the 10th of January through for a good 6 weeks or so. One of the things, once we get to this time of year, you need to check when you're looking at a range of sites. You need to, again, I've drawn down, click on the More Pasture button. When that comes up, at the very top of it, the first thing you see is some data about the grass grow farm system that we've modelled. And if you'll notice, the arrows going across to the pasture. So at this site, the producer said the pasture is made up of annual grass and subclover and phalaris. Now, we know it. Once we've got to this time of year, the annual grasses and subclover, regardless of how much moisture in the soil, will have set up seed, and they will just be desiccating and turning to dead feed, regardless of what we've got. Phalaris does the same thing. Phalaris has quite a dormant period in summer. So that sudden drop-off is occurring, even though we've got good moisture in the soil, but it's occurring because the plants have reached a stage of growth that, regardless of moisture, they're going to move from the green pool to the dead pool. Now, it looks pretty dramatic, and some people say, oh, God, I'm going to have no food in January. We are only showing you the green pool. Where that green pool drops off rapidly, you're going to be getting an increase in the dead pool. So this property, and in fact, all properties in Tasmania, are going to be carrying a lot of dead feed over this summer, right? So that fast drop-off is a function more of pasture species and where they are in the growth cycle, rather than it's dropped off because things are dry. Now, at some of the sites, the pasture species might have included phalaris. It includes native species that grow in summer months. So if you flick around the different sites, you'll find some sites that'll still have a little bit of green through summer, which is a reflection of where they are and also what species are in the pasture. So if you're looking at a graph and it's not making a lot of sense, go in and look at the pasture species that have been used to do the modelling. Thanks, Tim. Again, this is some of the stock information. Some people might say, oh, there's a mistake in this top one. What's going on? So these are, if we look over on the right-hand side where it says summary, it's the potential live weight of weaned male progeny. The reason the data only starts at about the 10th of January is the 10th of January is the date those stock are weaned. Prior to that, they're on mum, and we don't pick up the information. We start picking the information up when they're weaned. So that's why it's been truncated. Again, if you go up to that information that's provided at the top about grass growth details, it also has some information when's weaning, when a stock being sold. So sometimes if you look at it, why is it only there for part of the period when's weaning and when a stock's sold. Explain it. Again, always remember, shaded data is historical. The lines are the forecast. So what's that telling us at present is that regardless of what might happen in the next 4 months, these stock are performing in the upper band of where they would have performed historically. The bottom graph picks up males and females. Again, they're just the weaner part, and that's just presenting the data in a different way. What this is saying, remember, these forecasts are generated by 30 years of runs. So we have 30 years of data of what weight the weaners, females or males, might get to at the end of the planning period. And this is just another way of looking at the variation across the 30 years of data. And if we just look at the females, because we haven't looked at them before, the yellow line, what it's saying is the lightest of all the runs done, the lightest was sitting at about, we'll say 37 kilos, a bit higher, and the heaviest the females got to over the 30 years was 42 kilos. And, you know, for the vast bulk of the time, the stock were going to sit between about 38 and 40 kilos. So again, just giving you some indications. We've spoken about some of these weights, the value of the actual weights. We can't take account of animal health problems. So these would be at the upper end of what you might expect. But even with that, in having said that, the relative performance of where the stock are this year, the lines compared to the historical, is important. Thanks, Tim. Again, it's something we should check every time, but sometimes people just forget. The probe information on the left-hand side, I downloaded on Sunday night. The thing I wanted to bring your attention to is under the word probe, last update, Wednesday, 9:30 p.m. in red. So when I looked at that on Sunday night, I noticed that information in red. And what was that? That was telling me, even though I was looking at the data on Sunday night, the probe data I was looking at, they haven't had any data off the probe since 9:30 p.m. on a Wednesday. Now, we always get some transmission problems. The vast bulk of the problem is not the probe in this case. It's just that the data, there's been a break in transmission for some reason. Telstra might have, Optus could have been working on a tower and the critical tower was shut down for 2 days. On the right-hand side is the same probe data, which I downloaded at about 6 o'clock last night on the Monday. So in between, in 24 hours, the communication has been the probe has become active again. The information's going off. All the data that was measured between the Wednesday and yesterday has been uploaded, and now we're getting something that's slightly different. So we can see in that period of time that the 10 centimetre level has dried a bit. So always look at the dates up the top, because if things aren't going right, you need to bear that in mind before you go and look at the data. Thanks, Tim. Rightio, now I'm going to go through each of the sites on the east coast and just up into the Fingal Valley, and just talk about what we're seeing. So the one on the left will always be the forecast based on climatology, and the one on the right will always be the forecast based on Access S. And you can see that by just looking at which of the radio buttons have been activated. So the very first thing we look at is, how does the current position, which is the black line and the start of the forecast, compare to historical? So at this site, well above historical values. We are looking at levels of pasture this year that might never have been seen again in the last 30 years, or might be at the very top of it. Right, so straight away, current position forecast versus history, well above what we would normally expect. Rapid drop-off, we've talked about that, principally driven by the fact that that pasture is at a state where it's saying, I've had enough of growing. I'm shutting up shop. It is not moisture related. The pastures don't grow forever. At this site, we see there is some green always stays in the pasture in the wetter years. 50% of time we go through a period there where we've got no green food. So our forecast is running a hell of a lot better than the historical data. Let's go over to the axis on the right-hand side. The starting point is exactly the same. Are the coloured lines radically different from the left-hand side? The only thing I regard as being radically different is at the end of March. We'll notice the blue line, the 90% and the 50% have got a kick up in March, a substantial kick up towards the end. The other little bump differences in bumps, to me, they're that small, I don't worry about them. So summary, whether we look at climatology or whether we look at access, we're getting the same story. We're sitting in a very good position. That green food, just because stage of growth is going to move into the dead pool, and we are going to be carrying a lot of dead food over summer. And to some degree, and this, I could give us a summary now, which will apply to just about every site in Tassie and a hell of a lot of sites in New South Wales as well. It's the management of the dead food that will become the thing we might need to focus on. Next slide, please. We're just moving up the coast. I could say ditto to what I've just said at the last slide. Again, where are we sitting compared to history? Well above. We talked about the drop off. Interestingly enough, if we go to access again on the right, we are seeing that same kick in late March. Now remember, these lines are green feed. If we're going to get a kick like that in green feed in late March, it's because we've had to have had good rainfall events in either late February or early March. Because what we're seeing is the result, the rain's got to come, kick the systems off, and the response in feed. So the actual rainfall, if we could plot that, would be much earlier. I'd say it'd be indicating that they're saying there's a potential of rainfall coming in late February, early March, driving things forward. I'm very encouraged on the access graph. I'm most likely more encouraged by the response of the yellow 50% line than I am the blue line. Because if you think about it, the blue line is a 1 in 10. We've got a 1 in 10 chance of that response. When we come to the yellow line, that's a 50-50. We've got a 1 in 2 chance of getting that response. And that, if you look where that yellow has gone, by the end of March, it's got us sitting at the 90% position historically. So that's substantial. Next slide, please. Rightio. I'll just give you a chance to look at them both. Exactly the same with what we're talking about. And again, maybe go over the access S1 and focus on the 50% line. The 50% line there's even, its response is even a little bit stronger than what we've seen before. Not much I can add, mate. So same story. Now, just before you do move on, Tim, the fact that a number of sites geographically are giving us the same story is important. It's adding robustness to the data that was coming through. If only one of these sites was showing a potential good features for autumn, then you'd say to yourself, oh, well, it's only 1 out of 4, and if it's going to be something meaningful, it should be more than that. So the fact that each of the sites have got similar behaviour, it builds your confidence about what each of the sites are telling you. Next slide, please. We're now up to Gala. Now, Gala, I suppose, compared to the other sites, Gala is a native site, so we've got a lot of species that have summer growth patterns in there, so hence how the historical data set behaves. With the access, we're still getting a bit of a kick out of the 90%, not quite as strong. And that's partly driven by this site will in fact chew its way through a bit more moisture because we've got species that can grow, more active summer growers. But it's the response isn't as high, right? So we're not up in the white area, we're not above the 90% when we compare where we are historically, the end of the black line, start of the coloured lines. But we are still sitting in territory you don't see very often. We're nearly at the 90% historical level. So again, the graph looks a bit different, but the message we're getting has been no different from what we've seen at the other three sites. Next, please. And rightio, the last one is we've just gone and picked up the Killymoon site at the eastern edge of the Fingal Valley. Because really at the eastern edge of the Fingal Valley, there's still influence of, if this is occurring at Killymoon, logic says that some of the similar trends would be occurring on the east coast just below it. So this could give us a bit of an idea of what's happening on the higher parts of the east coast. So again, same principle of looking at it. How does our current position compare to history? No difference there. Some slight difference with the blue line between climatology and Access S. The blue line's pushed out a bit further, but again, that doesn't faze me that much. But even here in the eastern edge of the Fingal Valley, we're picking up this late autumn response. You know, you can see that yellow line going very strongly, the blue line. So that's encouraging. Now, how much emphasis do I put on the 1st of December, a response that's occurring in March? What do I say right now? I say it's nice that I'm seeing it being positive rather than negative, but we're still a fair way out. If when this is redone on the 1st of January, we again see these kick-ups in the month of March, when the length of forecast period is only 3 months, I start becoming more encouraged and positive by it. And then if we see it again in February, I've become very, very encouraged. So here we are at the 1st of early December. I'm glad the response out there in autumn is looking to be a positive as far as Access S is saying, but I'm not getting excited about it. If we chat again in January and early February, if it's still there, I start getting excited about it.
So Phil,
that's it. Yep.
So Phil, so just on that, for farmers, if you were looking at these two graphs, looking at climatology and Access S, which one would you tend to follow a bit more?
I look at both, Pete. I look at both. Yeah. I look at both and I look for trends. And to me, except for the last half of March, they're telling me the same thing. Right? And to some degree, that's not surprising, Pete, because we're most likely going to be going into summer carrying more moisture in the soil than we normally have. But we've grown an enormous amount of feed, and that feed's going to dry off. And that has now really become our limiting factor. It's how our pastures are. So if someone had a loosened paddock, which you were cutting for hay and grazing, so it was always available to be in a growth phase, with the moisture in the ground, we could get enormous growth rates through December and January. But with perennial pastures like we've just about got as much growth out of those pastures as we can get. So that's why they tend to drop off. And if you look to some degree, they become a bit non-responsive to moisture. Our biggest issue would in, say, January, if we get good rains again, we'll have that much dead sitting over the top of green material trying to come away from the base of perennials or annuals trying to germinate, that's going to be severely compromised by the overburden we have. So when you've got a season this good, I'm not surprised that the two graphs aren't. If we didn't have as much feed, the two graphs, there might be more divergence in it. But to some degree, the amount of feed has just made the two of them come closer together. I place equal weighting on the two graphs.
Yep.
I will place with the axis S, the closer the time period between when I'm looking and what part of the graph I'm looking at it. So if I'm looking only a month out, I will place more weight on that for access. I place less weighting on the forecast 3 months out. Because as we know, with any forecasting of weather is random and chaotic. The further you go out, the bigger the error bars. The closer you get, the tighter the error bars. Does that make sense?
Yeah. Yep.
Now, I didn't do it for this one, but I did it for the Midlands one. Sometimes when you're looking at access S to some degree, I might be inclined to get rid of the 90% figure and use the 75% as the top chance. So at some of the Midland sites, it was interesting that the green line, which would appear if I'd ticked 75%, it was almost behaving like the blue line was. Now, you say, well, so what? Well, the blue lines are 1 in 10. The green lines are 1 in 4. The odds of 1 in 4 excite me a lot more than the odds of 1 in 10. So I often forget about using the 90%. You know, that's if things are up there, geez, they're that good, we don't have to worry. I tend to often just go 10, 25, 50, 75 and never even look at the blue. So open to questions, Tim.
Yep. So yeah, feel free if you have any questions. We've got about 10 minutes to chat. I was just going to ask Marek also just while we're doing this. Marek, did you have any comments about the soil probes and the stuff that's Phil was mentioning at the beginning?
No. Apart from the fact that assessing soil moisture levels is an ongoing thing, and so making sure that we're working together to make sure that soil moisture levels are reading what they're saying on the probe and what's actually going on is a key on my behalf to make sure that this works well. I will just mention quickly while I pulled up that while you had that probe, that graph, Phil.
Can I'll go back to it. Which one was that? That one?
Yeah, I had a look at it, and I don't know if I can share my screen, but I've pulled it up here. So I quickly had a look and figured out pretty quick smart that it was the Benham site for that one. And essentially what's going on there. So last year that went into a paddock that didn't have very much pasture cover. So it was a pasture that was going to get renovated. So we took the punt to put it in first and then renovate the pasture over the top. This stage, last year there wasn't much going on, so our guess is in terms of getting accurate full point and I guess full point and stress point was very hard to do. Well, that now has gone nuts over the last week and a half. It's been drawing moisture down like you wouldn't believe. So that probe is behaving really well, but now we just need to update the numbers to match the water uptake that pasture is now demonstrating. So so that's an example of how something changes and we need to update the numbers there. So I can flick those through to you, Graham. I've just updated those, so I can send them your way, and that will reflect a lot better there.
Yep, thanks.
That's great.
I think that's just a good example of the longer a probe's in the ground, the better the information gets. Yeah, if you've got 5 years data, it's telling you a better job. It just moved too quickly for it to be purely pasture driven. And that's the one thing you find with probes. When pastures are in full bore in springtime, and we've had growth rates coming up on the site down here in November of over 100 kilos a day, Pastures chew through a lot of moisture very, very quickly, but that was just a bit too strong.
Well, has anybody else got any questions?
Tim, can you hear me?
Yes, can hear you loud and clear.
I've got a question relating to that graph. Our average pasture cover is nothing like showing here. It's 1,000. Well, I guess it's showing 5,000 kilos. The reality is probably closer to 2.5 to 3. Is that graph an average pasture cover, or is it net of and is it net of the stocking rate?
No, it's average pasture cover across your place at the stocking rates you gave me when we set it up. So this was running at a stocking rate of over about 22 or 23 DSE. So we've maintained the stocking rate. That's the sort of cover you should be seeing in your paddocks averaged across the whole farm.
Well, we've got quite a lot of paddocks even bared out because it's nothing like that. But I suspect that it's because so much country has been so wet that there just hasn't been the growth, and there's been pugging. But you'd think that it would have been picked up with the probe, but there's a big divergence.
Have you made any radical changes in stock numbers in the last 6 months?
No.
And what's the country look like? The rest of the place looks like. Have you got paddocks that have run to seed yet?
I've had to close up a couple of paddocks because they just were so wet that I couldn't even think of stocking them, and the feed's up over the fence there. But where I've put, I've stocked country for calving. I did set stocking at two cows to the hectare, and just opened the gates and left them to it because I couldn't even access them because I couldn't get across the river. And those paddocks are just totally decked. There's no feed on them at all.
Yeah, which is a result that the stocking rate you've run in those paddocks far exceeds what's in the model. Right, so we've got a situation that you have been, because of the wetness of the country, parts of your places you've run at stocking rates higher than what we've got, and some parts are running at lower ones. So the seasonal conditions will have explained, and the way you've had to graze your place because you had no other choice.
Well, two cows to the hectare is the same as the model. It's about 22. So
two cows to the hectare, Tim, is a lot more than 22. You're in the 30s.
Okay.
If you're talking about cows with calves on them,
yep.
Right, you're got stocking rates in the 30s.
Okay.
And I think in some of your country, which is exceptionally wet, the growth rates, pasture growth rates, will have been compromised. So your growth rates will be compromised to some degree, and how you've grazed it has compromised the scenario.
Yes, that's fair. Yep.
So if in areas that have been compromised because they're wet, you will find that this will, in reality, you will keep growing at a time where this is saying your things are dropping off. For those paddocks that are grazed bare, you've still got moisture in the ground, so to some degree spring hasn't arrived in those paddocks yet.
That's correct.
Yeah. So as we go through December, January, and the abnormal levels of soil moisture start petering out, we might find that what you're seeing and where the forecast line will get back into even kilter a bit better.
Okay. Thank you.
Just on that stocking rates, you'll have been working out stocking rates based on tables. Grassgrow works out stocking rates based on daily figures, and in an operation of yours, the DSEs you're running at, the tables you use most likely underestimate the DSEs you're running at.
Okay.
I've just thought I'd mention, I've just put a couple of questions up for the session, if you've got time to fill those in. But I just wanted to say, based on what Tim was just saying, what we want to do as well going forward is we want to keep hearing from everybody with their site, with the information that they're getting out of the sites, to make sure it's relevant, because as like we discussed, these are models. The information is only good as the model is only as good as the information that's put in. So there will be some tweaks and changes that will happen. So we really want to keep hearing your feedback, not just in these sessions, but if you're not quite sure about some of the data coming out, you know, please let us know. Please let Pete or myself, or even Phil know that, you know, what you're seeing is not quite right, and we'll take a look at each of the sites as needs be.
Tim, I just pick up. I don't think the word "quite right" is quite the right way. Tim has given me a lot of feedback over time, and for 12 months, what the model was producing and what Tim had in the paddock was accurate. It was matching very well.
Yeah, absolutely.
Right?
Yeah.
So we've now come to an abnormal period, which has resulted in some abnormal management, which will kick it off. Now, to say that, oh, the model's not right, is not quite, we're not quite there. And on the basis of Tim's comments today, I wouldn't change anything in the model.
No, it was just a general comment about what you're seeing. Please let us know if you've got any queries about what you're seeing. That's all. Yeah, that's all I was saying. Yeah. Yeah. Okay. Well, I think if there's not any more questions, I think we'll wrap up the session. Thank you all for coming. So I've just sent those couple of poll questions. Feel free to put any comments or suggestions for future webinars. We're hoping to run a similar session. Probably, I think we'll probably be looking at February, Phil, early to mid February for a follow-up session.
No, it won't be in February, Tim. It'll be early March.
Okay, my apologies. We'll make it early March. early March, yeah, for a follow-up session. So yeah, great. So we'll let you know how that goes. So I hope everyone found that useful. Yeah, we'll look forward to catching up again in March. So thank you, everybody. All right.
Thanks, Ted.
Thank you. I'll just stop recording now. Okay.